My talk will focus on the effect on probiotic consumption on gut microbiota on functional bowel disorders. Probiotics are live microorganisms that, when administered in adequate amounts, confer a health benefit on the host. This is very important because this definition allows to make a clear link between the beneficial effect and the microorganism. So you can find many systematic reviews and meta-analyses on the effect on probiotics and IBS. I selected one that is probably the more compelling one, published by Ford in 2014 in American Journal of Gastroenterology. Take-home message are done more than 35 studies performing more than 3,000 patients showed a beneficial effect of probiotics with a higher effect for bifidobacteria. When we look at the effect on probiotics on functional constipation that has been reviewed by Dimidi in 2014, you can see that only 10 studies have assessed the effect on probiotics in functional constipation. So fewer studies looking at the effect on constipation. And when we talk about constipation, it's well-defined functional constipation. However, there are some good effects showed on the stool frequency. The density of the microbe is changing a lot all along the GI tract in terms of numbers from 10 to the 1 to 10 to the 3 in the stomach until 10 to the 10 or 10 to the 13 into the colon. And also the composition is largely changing according to the environment. And then the dominant bacteria are not the same if you look at the stomach or if you look at the colon. So beyond this, there are many external factors that may impact the composition. Of course, diet, prebiotic, fibers, probiotics, but also many drugs like PPIs, laxative, and of course, antibiotics. So you can't consider microbiota as a unique system. This is a very dynamic system. Several investigations have demonstrated that there are factors that contribute to dysbiosis in IBS. So there is an unstable gut microbiota that may impact the gut physiology and also on the other hand. And sometimes it's quite difficult to know what is the cause or the consequence. But what has been shown is that there are an impact on altered physiology, like on motility, transit, but also on the host immune system. And you have to keep in mind that also external factors like stress can impact the composition of gut microbiota. There is also good evidence supporting an important role of gut microbiota in constipation. First of all, the bile acids are deconjugated by several microorganisms, and this may impact the secretion, the motility. Fibers and poorly absorbed carbohydrates are metabolized in the colon to produce short-chain fatty acids, well known to promote the motility. And you have also some individuals that may harbor methanogens, and the production of methane is known to slow down the transit. Now we are able to use different methods to address different aspects of the microbiota. And this is the combination of these methods that will allow looking at either the composition, who is there, or what the microbiota is doing. There are many specific alterations, most of the time linked to specific subgroup of IBS, meaning that to date, there is no unique signature of an alteration of microbiota associated with IBS. We have no data also assessing what is the variation along the time during 6 months or 12 months that may explain if the microbiota is also changing with the symptom changes that we all know are occurring in IBS. So now let's have a look on how probiotics can modulate gut microbiota on GI, in relationship to their effect in GI function and IBS symptom. First of all, we have to think about how microorganisms can play on that system. As we have seen, there is different numbers of resident microbiota, and when you hit a probiotic, you will have a relative abundance of the ingested bacteria compared to the resident bacteria that is strongly different if you look at the stomach, where the ingested bacteria are dominant, and they become less and less dominant and minor when you think about the colon. The other important point is that, as you can see, with the transit time in stomach, small intestine, and colon, this is a very dynamic system. So this means that living microorganisms that could survive all along the GI tract may exert different potential health benefits at different levels. And most of the microbiome analyses have been performed in fecal samples. This may mask higher effects that may occur in the small intestine that you will not be able to detect in fecal samples. So even if you can collect some biopsies, sometimes this is very hard to access to the small intestine to get a precise assessment. There are only 7 studies available to date that have explored the impact of different types of microorganisms on the composition on the gut microbiota. Let's have a look more precisely in the study performed by Vega. So they tested a specific fermented milk containing a strain of Bifidobacterium lactis and 4 lactic acid bacteria. So this study was performed in IBS women with predominant constipation. The clinical results of that study have been published by Agrawal. So during 4 weeks, subject consumed 2 servings of 125 grams of product or a control product containing no bacteria. Stool collection was performed before and at the end of product consumption. The DNA was extracted. The whole genome sequencing was performed on this DNA, and after they map disease sequencing to a catalog, an existing catalog of genes containing 3.3 million of genes. Thanks to a bioinformatic pipeline, they were able to reconstruct, to associate disease genes to known and unknown species. And after, they look at the relative abundance of disease species in both product group and control group. And the last point was they identify some specific genes involved in some metabolic pathways. The first step was to check whether we can retrieve the DNA of the ingested bacteria into stools. So by using specific genes for each bacteria, they were able to detect an increase of the DNA. I was talking about the DNA, not the survival, but the DNA of the strain, of each the strain in stools. And as you can see in the control group on the right, there is no changes. The higher increase was observed for the strain of Bifidobacteria. After that, they look at how many genes are modulated by the consumption of the product and how many genes are also modulated by the control product. This is very important because when you test a food, you have to compare to another food, and just the fact of eating a food may have an impact of the microbiota. And twice more genes increase or decrease with the product consumption. So 1,320 genes were modulated with the product and around 60 in the control group. Interestingly, about 25% of the genes were not allocated to a known or unknown species. This highlights the fact that we are not knowing everything in the gut microbiota, and more research is required to identify to which species can be associated some genes. After that, so they look at which species can be modulated, and they identify 5 species that have been increased, for which the relative abundance have been increased. Among the 3 strains, so 3 were Bifidobacteria, and they have also observed the decrease in 3 other species, and especially Bilophila wasdorfia, that is known as a pathogen. So This is important to see that you can increase or decrease different species with the same product. This is the last part of this work. So they try to identify the genes involved in the metabolism of the butyrate. And they clusterize the different genes belonging to the same metabolic pathways. And after that, on this chart, so you have the 39 clusters belonging to the butyrate pathways, and they have observed an increase in 2 of these modules. So this may show that the consumption of this product is able to increase the genes involved of the butyrate production. The conclusion of this pilot study is that this specific product is able to modulate the gut microbiota. These changes have been demonstrated using species-level methods. And this is an important point because if we use in such studies a 16S method, it's likely that we will not observe any change. As a general conclusion, so there is really a good rationale supporting a potential role of gut microbiome in IBS and also a potential impact of probiotic on gut microbiome that may explain the clinical effect of disease strains. There are clearly an unbalanced number of studies if you compare those performed on clinical effect and those on the gut microbiome, and only small sample size studies have been done. So there is a clear need for a repetition on the same strain or the same combination of strains. We absolutely need specific study designed to look at the gut microbiota as the primary outcome. Most of the studies were looking at gut microbiota as the secondary outcomes. Both activities and composition should be assessed. This is mandatory to have the same probiotic use in independent studies to confirm the findings and long-term studies because we may expect different changes with a long-term consumption with different time points. And this is very important to look also to control the confounding factors like drugs, fibers, and this is it's likely that there are a huge interaction between the fibers consumption and the probiotic consumptions. So this is really the field that should allow identifying which subject will better benefit from specific probiotics. And this is probably at the individual levels that we will better understand. Thank you.